All right, everybody, here goes a video on just some trig identities stuff that you're going to need to know. Now, this first box is just going to give you some of your basics. The reciprocal identities, you know that tangent is sine divided by cosine, which means if you were to take the reciprocal of both, the cotangent is cosine over sine. And then you have your three different Pythagorean identities. So what we're going to do is use those into proving identities and simplifying some complicated expressions. So these are just a list of tips of what you can do to simplify and prove certain identities. So what we're going to do is, as I mentioned, these videos are going to be short. I'm probably only going to do a handful of problems in them, and the rest can be for you to try on your own, check with the answer key, or just wait till class time so we can talk about them together. The reason why is because my video is not going to do them in multiple ways. All of these questions, for the most part, can be done in different ways. You can do them in different styles, showing different steps. So I don't want to just narrow your vision into my way and only my way. So some of these questions I will do with you, others I want you to try on your own so you can see if you end up with the correct answer. So just keep that in mind. I'm not doing everything. So the first example, the directions say simplify to a single term. So you always have to read the directions because there are going to be different things that are going to be asked of you, and you'll see that in a few minutes. So this says just simplify down to a single term. I see two ways you can do this problem right off the bat. The first way would just be to bring this up to the top, and then you would just have sine squared. Or the other way is to realize you have cosecant on top and cosecant squared on the bottom. So this is just like saying x over x squared. If you have more on top or more on bottom, yada, yada, yada. So the first thing I'm going to do is I'm just going to say that this is going to simplify to tan x over cosecant x, because we had 2 on the bottom, 1 on top. When you simplify, there you go. Now what you want to do is you want to get rid of your denominator. So we know that cosecant is the reciprocal of sine. So if cosecant is in the denominator, we can rewrite that as sine on top. So we have tan x, sine x. And to be honest with this problem, you're actually done. If you wanted to say this is sine over cosine, what's going to happen? You're going to have sine squared over cosine. So now you're going to have a division again. So you just want to leave it here. There's nothing else you can do to simplify. Okay? This next example here, this is a subtraction of quantities here. So one of the things you have to think about is what can we do to get these terms to be the same? We can't subtract a tangent from a secant. We can't subtract a cotangent from a cosecant or anything funky like that. There'd be no combining like terms taking place here. So what you need to do is you need to go back to that first page and you need to use a little bit of Pythagorean identities. So one of the things that you can do is you can use the cosecant squared x, and you can change cosecant squared x to 1 plus cotangent squared x. And then, of course, that's still going to stay with it. So we have secant squared x plus 1 plus cotangent squared x. Okay, so that's all I did so far. Minus. And what we're going to do for this piece is we're going to change the tangent squared x. So tangent squared x we can simplify to secant squared x minus 1. And then, of course, our plus cotangent squared x. Now, the reason why I did that is because that got us to all terms of secant and cotangent. Now, from there, obviously, you're just going to distribute your negative sign. So this is going to give you secant squared x plus 1 plus cotangent squared x minus secant squared x plus 1 minus cotangent squared x. And our positive secant squared and negative secant squared will cancel. Our positive cotangent squared and negative cotangent squared will cancel. And we're left with a positive 1 and a positive 1. So this all simplifies to the number 2. And that's it. you're done. There's nothing else you can do with this problem. Now, of course, there could be other ways that you could have done that. Maybe you could have simplified the secant and the cotangent. So the way I do it is not the only way you can do these questions, okay? There are two more examples in these, but as you can see, these get a little lengthy from time to time. I want to save number 4 for you to try because that one is a pretty big challenge. But of course, you can try it on your own and check with the answer key when you're done, or you can save it till class. So number 3, here we go. This one says you are going to write in terms of sine and cosine. So again, different directions than what we had for 1 and 2. So you might be able to simplify these more if this was just simplified to a certain term. But these want to be simplified just to sine and cosine only. Okay? So, first step, let's get rid of anything that's not sine or cosine. We know that cosecant is the reciprocal of sine, so that'll just go downstairs. So this is going to give you 1 over sine x, plus, we can bring this secant down, which would be 1 over cos x, cos x. And of course, you want to simplify those. So that's going to become 1 over sine squared x plus 1 over cosine squared x. Now you have to remember what we're doing. We are simplifying. So we need to add these fractions together, and just like any other chapter that we've worked with, when you add or subtract fractions, you need a common denominator. So your common denominator, LCD, is going to be sine squared x, cosine squared x. So this side needs a cosine squared x, and this side needs a sine squared x. Now you have your common denominator, so the top is going to be cosine squared x plus sine squared x all over cosine squared x times sine squared x. And you're almost done. There's only one more step. And if you're noticing it, on the top you have sine squared x and cosine squared x. This is one of your Pythagorean identities. So sine squared x plus cosine squared x is equal to 1 over cosine squared x sine squared x. So if you're thinking about doing anything else here, you shouldn't. You're done. That is your final answer because we're simplifying to sine and cosine only. If you bring those to the top, you're going to have secant and cosecant. If you try to do Pythagorean identities with that, then you're going to have another mess to work with. So you are actually done. There's nothing else you can do to simplify this further and keep it with sine and cosine. So you are actually done. Now what I will do for this problem is just kind of start you off. I will say that you need to FOIL secant y plus cosecant y with itself because of the squared. After you do that, you will need to distribute the cotangent y. That's the little hint I will give you. But for now, that's it for this video. This is Longo and I'm out. See you, bye.